We are back
for the last installment
of Acids and Bases.
Woohoo! We're almost done.
So yeah, do your work, get it done with. We could be testing out within a week or so.
Yeah,
These units get
I want that next Friday. Big time.
quick, so we can be ready.
Reactivity series, real quick. This is a little short topic.
Yes, very, very short video, very short topic. This is very simple, really.
Right. So one of the things that separates an acid from a base is that acids will react with metals. Metals. And there's a table J we're going to learn how to use. And I'm going to basically ionize and form a salt and hydrogen gas.
Yes.
And that's what makes it all bubbly, so I see that it's happening.
Right. Acids react with metals. It's kind of just like a fact.
Yeah.
In the process of reacting, it's being neutralized. So metals aren't really bases, but because of the way the acid reacts with the metal to produce hydrogen gas, there's no more
acidic power.
hydrogen ions in there.
And so you can see it here, how that hydrogen 2 gas, it's going to go away. I don't capture it.
Right.
Because it goes off into the atmosphere, I can't push it back into the reaction and make it go back.
Right.
It loses that power, that hydrogen ion power.
For sure. And it's not even an ion anymore. It actually, 2 hydrogen ions react with each other to perform a hydrogen produce a hydrogen molecule.
Yeah. And
it's not ionic, it's not acidic, it's gone.
Is there an oxidation reduction going on here that we're not?
There is a redox.
So we can't get into that yet. That's 2 or 3 units from now. We'll get there.
Will eventually.
Let's learn how to read this table.
Table J is simple. It's called the activity series, and it rates the metals as the most reactive to the least reactive.
Right. And this one is blatantly right there. It says most reactive on top and least reactive on the bottom. So this one teaches you how to use it in case you forget, which is really nice.
An interesting connection to things like earth science and geology is that the most reactive metals are never found in a pure form in nature. They're always found bound up in minerals or salts. They react with anything they can get their hands on.
That was part of what we did in metals.
The least active ones are the ones that you might be able to find out in nature in the bottom of a stream bed or something.
The ones that are least reactive are the most precious to us. They last the longest. Gold,
AU.
silver.
It's right there down at the bottom there.
Yeah.
So that being a pure metal back in antiquity's time, like, wow, this is shiny and it stays shiny. It doesn't react. Let's make money out of it.
Yeah.
Everybody wants it. So it's least reactive makes it most valuable, at least in some people's eyes.
Sure. So then when we do it is, you see H2 on that chart?
You know, circle that.
Oh, can I?
Yeah.
Right there's H2, which is, of course, not a metal.
Yeah. So you might be calling, hey, H2, it's on the metal side. What the heck, man?
There you go.
The reason's there.
Because if I'm above it, I will react. And if I'm below it,
I will not.
I will not. It's as simple as that.
So H2 is squeezed in there so that we can do this, saying which metal is going to react with the acid. Well, if it's more active than the H2, it will react, like Mr. Milk said.
And here it is. If it's less reactive, then it won't.
So that's why things like copper, silver, and gold are really good for jewelry, because the acid in your skin don't react with it. That's why my wedding ring stays nice and shiny all the time, because my skin oils and acids won't react.
So the nice thing about that is this stays looking the way it does, and better yet, my finger doesn't change color.
Exactly. So if you ever get some cheap jewelry, might have some nickel in it,
right?
Turns your skin a little green.
Right. Or the earrings make your turn a little black.
Yeah, because your body reacts with it. The less reactive the metal, the more precious it typically is. But in this lesson, we're talking about acid versus metal.
Right. And when we did neutralization reactions, double replacement reaction that we had to reverse and revisit. Now it's single replacement.
Yeah, single replacement. They're technically redox reactions, but we're going to do a whole unit on that later.
Yeah, let's do that later.
Remind me to put these reactions in that unit so we see them again.
I can do that.
So Mr. Milks
I'm back to the board.
Is going to show you how to predict the products of
there's my H
plus metal. It's got hydrogen. There you go.
And so now I want to find out, is lithium higher than H or below H?
So he's looking up here.
Lithium. Oh,
there it is on top. More reactive.
Higher.
So we know that HCl will react with lithium now. And so he's going to swap the Li and the H to make the new products. And the other thing it always makes is really easy, H2 gas. Because we got to balance this equation. Yep. There it is.
Woo.
Squeeze some 2s in front of your HCl and your lithium chloride
Okay.
to balance it out. Now he's going to look at the next one. This is
Okay,
a
there's no H.
diprotic acid. It's got 2 hydrogen atoms on the front end there. He's going to react it with
There's no
magnesium.
Magnesium.
Always
Let me find magnesium.
compare.
There we go.
There it is. So magnesium is more reactive than hydrogen, which
So-
means they will react.
They will
produce- Swap the Mg
So
in for the
Mg.
H's. Mhm.
And I got an SO4,
And
an H2
H2.
gas.
and we don't have to balance this one
Oh, this one's good.
because of the charge balance technique.
Sweet.
Everything works out. Okay. The next one, HCl plus Ag, silver. Okay.
Okay, so there's my H2. And
There's
AG's
Ag.
down there.
So what would you write? Ag is less reactive than
Well,
H2.
it's not going to react.
So what would we write?
I would say there's 2 correct answers personally. I would basically say
HCl plus
plus
Ag.
AG.
Or I would say
no
reaction. That's exactly what would happen. So let's be honest. There's only 3 metals that won't react with acid.
Right.
Copper, silver, gold.
Right. So everything else will.
Yes, to some extent. And the higher you go up, the faster it'll react. So lithium will do it extremely powerfully.
Right.
Lead, sluggish.
Right. We are going to actually revisit this again next unit in kinetics 2 for
Concentration.
no.
How do we do that?
Spontaneous and non-spontaneous.
Ah, yeah.
Will it go all by itself?
We'll look at
It
the
won't
table
just be
again.
hydrogen, it'll be 2 metals instead.
So table J is really useful for primarily figuring out if an acid is going to react with a metal.
Yep.
The honest answer is most of them will react except for those 3.
Yep.
Copper, silver, gold. And then in other units, we're going to use this for a different technique. But that's it.
That's it.
Acids react with metals.
And we are done.
See it?